Hi all, today we're going to look at the real zeros of a polynomial function, and you can find the zeros of a polynomial function a couple of different ways, but the first thing we're going to look at is the remainder theorem, and this just states that when you have the function and you divide it by x minus c, if you plug c into the function, whatever you get, that is your remainder if you were to divide. So let's try this out with the first example. We have x minus 3, so that means our c value equals 3. We're going to go ahead and plug that into the function. So 3 cubed minus 4 times 3 squared minus 5. 3 cubed is 27. 4 times 9 is 36. And then minus 5. And this simplifies to be negative 14. So our remainder of that polynomial divided by x minus 3 is negative 14. Now let's try x plus 2. And now it's a plus 2, so it's opposite. So that means our c value would be negative 2. Because if we plugged it in, we'd have that double minus, which is x plus 2. So let's go ahead and plug in negative 2 into the function. So negative 2 cubed minus 4 times negative 2 squared minus 5. Negative 2 cubed is negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. Negative 2 squared is 4. 4 times negative 4 is negative 16 minus 5. If you simplify this, you should get negative 29. Alright, so the next thing we're going to look at is the factor theorem. And this just states that if you factor a polynomial by x minus c, that is a factor if it equals 0. So let's go ahead and try this first one. We have an x minus 1. And so we can use the remainder theorem, or we can go ahead and divide. I'm going to do the dividing so we can get a practice in synthetic division. So for my 1 would go in the box, and then 2, negative 1, 2, negative 3. I'm going to drop down the 2. 2 times 1 is 2. That's 1. That would be 3, 3, and 0. This last value here is our remainder, and our remainder was 0. So therefore, this x minus 1, therefore x minus 1 is a factor. All right, let's try x plus 2. So if it's x plus 2, our c value is negative 2. That goes in the box. And then we write the coefficients of the polynomial. So 2, negative 1, 2, negative 3. Drop down the 2. Negative 2 times 2 is negative 4. Add those, you get negative 5. Negative 2 times negative 5 is 10. Add those, you get 12. Negative 2 times 12 is negative 24. If you add these together, you get negative 27. So our remainder here was negative 20. Therefore, x plus 2 is not a factor because it didn't equal 0. Next thing we're going to look at is using the P and Q method. So the P is the last value in the polynomial, and the Q is the coefficient of your first value in the polynomial. So in this example here, our P would be negative 6, and our Q would be 2. And for this example here, they just want us to list the potential values. So what you're doing is you need to find all of what multiplies to either the P or Q. Like, what are its factors? So when we think of negative 6, we have plus 6, a positive 6, and we could have a negative 1. We can also have the opposite of having a negative 6 with a positive 1. What else is there? We have 2 and 3. So we could have a positive 2 and a negative 3. Or we could have the opposite and have a negative 2 but a positive 3. So those are all our factors of the P. Now let's try the Q. So we have a 2 times 1. And we could have a positive and a positive. So positive 2 times positive 1 is positive 2. We could also have 2 negatives. So negative 2 times negative 1 is positive 2. So those are our factors of 2. Now, the next step is to do what P divided by Q is. So this is each value, each P factor divided by each Q factor. So plus or minus 6 divided by plus or minus 2, plus or minus 6 divided by plus or minus 1. And then you continue this. So plus and minus 1 divided by plus minus 2, plus minus 1 divided by plus minus 1. I'm going to move this up just to get some more space. Plus minus 2 divided by plus minus 2, plus minus 2 divided by plus minus 1, plus minus 3 divided by plus minus 2, plus minus 3 divided by plus minus 1. You can simplify these to get P divided by Q is 6 divided by 2 is plus minus 3. 6 divided by 1 is plus minus 6. That's 1/2. 1. 2 divided by 2 is 1 again. 2 divided by 1 is 2, so that's a new one. 3 divided by 2, that's 3/2. And then 3 divided by 1 is 3, and we already had 3, so we don't have to list it again. Now, let's go on to the next question. Find the real zeros of the function that we were just working on and write it in factored form. But we're still going to be using that P and Q theorem. So we already listed all the potential zeros. That's what we did by using P and Q. So we already listed all those potential zeros, and we need to see if any of them work. So first of all, we need to know how many possible zeros can there be. This has a degree of 3. So that means there could be 3 possible zeros. 2, you want to list your zeros. And we did that above, so we can copy that list below. So plus minus 3, plus minus 6, plus minus 1/2, plus minus 1, plus minus 2, plus minus 3/2. Next, we are going to use a calculator, because to go through all of these potential zeros and try and figure out which one it is, there's a negative and a positive 3. There's a bunch of those zeros from our list of potentials, but we're going to check out the graph to see which ones appear to be a 0. So I already plugged it into the graph for us. So I'm going to hit plot, and let me see. So I'm going to find the function root. It looks like one of the zeros is 1. Another is negative 1/2. And the third is negative 6. So we locate the zeros with calculator. And that ended up being negative 6, negative 1/2, and 1. That's where it appears to be located. So we're going to check if those ones that we think appeared to be a 0, if it was actually true. So we can go back and use that factor theorem of trying to get that remainder of 0. So we can go ahead and we would have our C value of negative 6. Then write all of our coefficients of the polynomial. So 2, 11, negative 7, negative 6. Drop the 2, 2 times negative 6 is negative 12. That's negative 1. Negative 1 times 6 times negative 6 is 6. Negative 7 plus 6 is negative 1. Negative 6 times negative 1 is 6. Negative 6 plus 6 is 0. We had a remainder of 0, so that means negative 6 is a 0 of this function. So we can go ahead and say that x plus 6, because remember it's the opposite, is one of those zeros. And then we would, when we rewrite the other polynomial that we would multiply, you use these coefficients from the synthetic division and drop the highest degree. So our highest degree was 3, so now we're going to have an x squared, and then minus x minus 1. Now we're going to factor what's left in with that quadratic to find those other two zeros. So let's go ahead and factor. I'm going to factor over here on the right. I need two numbers that multiply to negative 2 and add to negative 1. And that's negative 2 and 1. And so I'm going to rewrite the function minus 2x with those values I just found, plus x minus 1. And then factor by grouping. 2x they have in common, so an x minus 1. And they just have a 1 in common, so I'll put a 1 out in the front. Our parentheses are the same, that means we did it right. So we have 2x plus 1 times that x minus 1. And then don't forget our x plus 6. And then if we set these equal to 0, we would find that they matched perfectly with those zeros that we listed from the graph. But doing this division part proves that those are zeros of this polynomial. All right, we're going to try this again with this last example. So we want to first, again, what is our possible zeros? It has a degree of 5, so 5 potential zeros. 2, list the zeros. So we need to do the p divided by q again. So the p value is 48, q is 1. So we just need to list those factors of 48, which can be, let's say, 1 plus or minus 1 plus or minus 48. There's also 24 and 2, so plus minus 2 plus minus 24. There is 12 and 4. So 4. We also have 8 times 6. And I believe also 16 times 3. So plus minus 16 plus minus 3. And then factors of 1 are just plus minus 1. So if we go ahead and do p divided by q, we just get what we listed above of plus minus 1, plus minus 48, plus minus 2, plus minus 24, 4, 12, 8, 6, 16, and 3. All right, next step, look at graph. So I'm going to go and look at the graph. I already put it in the calculator, so I'm going to press plot. And it looks like right here we have a 1 of 2.00000, so about 2, okay? And then we will have one right here of negative 3. So when we look at it, we looked like we had one at x equals negative 3 and 2. I'm going to check the -3 one because the 2 was 0.0000 something. So I just want to use the x equals -3 to check in step 4. So again, put that -3 in the box. Write your coefficients. So 1, -1, -4, 8, -32, and then 48. We will drop the 1. 1 times -3 is -3. -1 plus -3 is -4. -3 times -4 is 12. 12 plus -4 is 8. 8 times -3 is -24. 8 plus -24 is -16. -16 times -3 is 48. 48 plus -32 is 16. 16 times -3 is -48. Sorry, remainder is 0. So that ended up being a factor. So we had, and remember, write it as the opposite when you put it in the parentheses of the x minus c form. And then rewrite our coefficients here and drop your highest degree. So our polynomial originally had an x to the 5th, so now we're going to have an x to the 4th minus 4x cubed plus 8x squared minus 16x plus 16. We have another x to the 4th, so you could keep continuing to try and factor. Otherwise, I say this is okay, and we're going to leave it here because when we looked at the graph, it really only had that one x-intercept. Even though there was a possible of 5, there was only that one. So please ask me if you have